Good day, ladies and gentlemen. Today, let's talk about Java. But before that, let's have a short discussion about Java. So let's start. Java. It is a high-level programming language, object-oriented, graphical user interface. Moreover, let's talk about the history of Java. Java, it is developed for World Wide Web or www.org. It is the first name of Java. In the year 1990, Java first developed. In the year 1995, Java is published under the Sun microsystem. Then, Java is developed by James Gosling. Java Platform is a new platform different from any other platform like Windows, Macintosh, and Unix. API, Application Program Interface, building blocks of applications. Lastly, the two environment of Java, J2 SDK, Java 2 Software Development Kit, JRE, Java Runtime Environment. After knowing everything about Java, let's now proceed to make a simple program using the Java application. But before that, you need to download these either of the two, NetBeans 6.8 or NetBeans 6.9, okay? So let's start. Okay, let's start. Wanna open up your NetBeans. Click the file, new project, then next. Rename your project name with your desired name. For example, project 1, project 2. Finish. Right click to your project name, choose new, Java class, then rename the class name with your desired class name, for example, hello. Then click finish. You see the environment, okay? You can see clearly the codes in your new Java class, then type the following. Import java.io.asterisk semicolon. You have the default class name, then public static void main string args. Arg stands for arguments. Then system.out.print line hello world. Don't forget the semicolon after the statement, then curly brace. And that's it. And that's it. After typing your code, click to the hello.java, right click to that, then click the run file, and that's it. You will see hello world. You can use the shortcut key Shift F6 if you want to run your program. And that's it. It's your simple program using Java. And that's it. That is your simple program using Java. After making your simple program using Java, let's now proceed to discuss about the three types of list.
Linked list, a list implemented by each item having a list to the next item. List, a collection of items accessible one after another, beginning at the head, ending at the tail. Link, a reference, a pointer, or access handle another part of the data structure. Head, the first item of the list. Tail, the last item of the list. Okay, now let's proceed. This is the example of linked list, the collection of items. List item 1, list item 2, list item 3, and list item 4. The first item of a list, which we call the head, the last item of a list, which we call the tail. List item 1 is linked to list item 2, shown by a pointer which we call a link. List item 1 is not linked to list item 3 because he must first link to list item 2 before going to list item 3. That is the process of linked list.
The second one is circular linked list. All nodes are linked in a continuous circle without using null. For list with a front and a back, one store a reference to the last node in the list. The next node after the last node is the first node. Elements can be added to the back of the list and removed from the front in constant time. Circular linked list can either double or single.
So after saying all of those things about linked list, let's proceed to the two examples of linked list. The double linked list and the circular linked list. First is the double linked list. Double linked list is a variant of linked list which each item is linked to one another as well as the next. So let's proceed to the next topic. This is an example of a double linked list. Every linked list has an item. This is the first item, A1, A2, A3, and A4. We know that A1 is linked by A2, and A2 is linked by A3, and A3 is linked by A4. So, this is an example of linked list. Now, we can say that this is double list because A4 is now linked with A3, and A3 is now linked with A2, and A2 is now linked with A1. This is the process of double linked list.
Now you know linked list. Let's proceed to stack. Stack is a list with a restriction that inserts and deletes can be performed in only one position, namely the end of the list is called top. There are three fundamentals operation on stack. Push used to insert, pop used to delete, and top as a result.
We have here the example of stack. So now let's proceed. We have here elements A1, A2, and A3. Step 1. Push element A1. We're going to put the element A1 at the first stage. Step 2. Push element A2. We're going to put the element A1 at the second stage and the element A2 at the first stage. Step 3. Pop A1. Push the element A1 to the stack and the element A2 at the first stage. Step 4. Push element A3. We're going to put the element A2 at the second stage and the element A3 at the first stage, and the element A1 will remain at the stack. This is the process of stack.
Now, you learn about linked list and stack. Let's proceed to the queue. Queue, like a stack, queue are lists within a queue. However, insertion is done at the one end, whereas deletion is performed at another end. And we will use the process FIFO. It means first in, first out.
A. This is the representation of queue. But first, we have to know the two fundamental operations of queue. First is the enqueue or insert. It inserts an element at the end of the list. And the second one is the queue or deletes. It deletes the element at the start. And now, let's proceed to the example. This is the example of queue. First, we will enqueue the first element. The first element should be at the last corner of the array list. The first element will be called the front and also the rear. Then, we will enqueue another element, the element 2. The element 1 will be the front and the element 2 will be the rear. And then we will enqueue another element, the element 3. The element 1 will be the front and the element 3 will be the rear. Then lastly, we will dequeue an element, the element 1. The element 1 will be deleted and it will called the null. Then the element 2 will become the front and the element 3 will become the rear. That's the process of the queue.
So let's start again. Binary tree. A tree in which no node can have more than 2 children. The binary tree is divided into two, the left and the right part of a subtree. The subtree on the left of a node is referred to as left subtree, and the subtree on the right of a node is right subtree. Tree, or also called as data structure, a collection of data items called nodes. This representation you see on your screen is what you call tree. Root. This one, yes, this one. That one is what you call the root. The node at the top of the tree. Subtree. These are the subtrees. The tree, which is a child of the node. Parent. In this diagram, these two are the parents. The tree node conceptually above or closer to the root than the node and which has a link to the node. Child. In this diagram, these are the childs. These are. An item of a tree referred to by a parent item. Nodes. A unit of reference in a data structure. All these items are what you call nodes. Okay? Link. A reference, a pointer, or access handle to another part of the data structure. As what you've seen on your screen, these pointers, this, and this, are what you call the link. Leaf or leaves or terminal nodes, a terminal or bottom item of a tree with no child. In this diagram, this is the terminal node. As what you've seen, this item has no child, okay? Internal nodes, a node of a tree that has one or more child nodes, degree. And this one, this is the internal. Then the parents who has 2 or more children, okay? Degree. The number of subtree of a node in a tree. You will count on how many subtrees do you have in this diagram, okay? That's it. That is the binary tree. Moreover, expression trees is a binary tree representing a mathematical expression. The leaves of an expression tree is what you call operands. And the root of the tree and the root of all subtrees are what you call operators.
Today I don't feel like doing anything. I just wanna lay in my bed. Don't feel like picking up my phone, so leave a message at the tone. 'Cause today I swear I'm not doing anything. I'm gonna kick my feet up, then stare at the fan. Turn the TV on, throw my hand in my pants. Nobody's gonna tell me I can't. Nah, I'll be lounging on the couch, just chilling in my Snuggie. Click to MTV so they can teach me how to Dougie. 'Cause in my